Okay, Year 12s, welcome to our first video on logarithms. Let's see how this goes. I'm just going to prop this up here. So we're looking at logarithms today, which are definitely new to you. And the first thing we need to learn about is how to rewrite exponential equations in log form and vice versa. So a logarithm is basically an inverse of an exponent. So in this little thing here, I've got a to the power of n equals b is equivalent to log base a of b. So for example, if I've got 2 to the power of 4, then that gives me 16. So this part here asks me if I multiply 2 by itself 4 times, 2 times 2 times 2 times 2, what do I get? And the answer is 16. If I rewrite this expression as a logarithm, the question changes. My base is still 2, log base 2, but the question is now, if I have a base 2, how many times do I have to multiply it by itself to get an answer of 16? And the answer to that is 4 times. So the answer to a logarithm is the power. So I say log base 2 of 16, and this number 16 in there is called the argument. Okay, that's just the word for it. So here's another example. 3 to the power of 4 equals 81. We can rewrite that as log base 3 of 81 equals 4. Now, a logarithmic function is the inverse of an exponential function. That means if I start with y equals a to the power of x, I can rewrite it as a logarithm. My a is the base here. My y, that's the argument, is the answer over here. And then this x is the power in the exponential equation. Now, if I want to find the inverse, I just swap x and y. That's how we find inverses. So if I swap x and y, I end up with log base a of x equals y. So I get y equals log base a of x is the inverse of y equals a to the power of x, which is what I started with over here. So if they're inverses of each other, then that means that if I take the opposite, if I go a to the power of log base a of x, then I get x. And if I take log base a of a to the power of x, then I get x. Okay, let's pause there.